the last few videos, we learned how to perform hypothesis testing using a Z and several different types of t-tests. I would encourage you to watch those videos before watching this one. In this video, we will learn how we can use Python to perform hypothesis testing. Let's say we want to test the hypothesis that the daily return on S&P 500 index during the first decade of 2000 is different from 0. In this simple experiment, we don't care if we generate a positive or negative returns. All we need to know is if the returns for the first decade are different from 0. So in this case, our null hypothesis is that the daily return on S&P 500 index during the first decade of 2000 or mu is equal to 0 versus the alternative hypothesis is mu is not equal to 0. Since we define our population as the first decade of 2000 and we can find all the data for the population, we can calculate the population variance and hence use of ztest statistic in this case is acceptable. Even if we did not know the population variance, we could still use the ztest since our sample is large. Let's see how we can use Python to test the hypotheses. First, let's import our standard libraries. For ztest, we will also need to import weight_stats module from the statsmodels.stats. Finally, to calculate t-statistics, we will need to import stats from SciPy. Now let's download the daily index prices from Yahoo Finance for the first 10 years of 2000. Let's call the new dataset SPY. This is the ticker for S&P 500 index. Let's select the start date as 1999-12-31 and the end date as 2009-12-31. Once we execute this code, Python will pull the S&P 500 index data from Yahoo Finance. Now let's calculate the log returns by executing the following line of code. In general, it is a good idea to visualize our data to check for any errors. We can use the head function to look at the first 5 rows of the data. The first observation for log returns is not a valid number. Let's drop this first line of dataset with missing observations for log returns. We can use the drop_NA function to do that. The in-place option replaces the old data with the new one without the missing observation for log returns. Now let's compute the ztest statistic and the associated p-value by using the ztest function from the weight_stats library. We need to select the variable of interest, which is log returns, and if we want to perform a two-sample mean test, we can add the second variable as x2. But since we have only one mean, we enter none for x2. Next, we need to enter the comparison value from the null hypothesis, which is 0 in this case. And finally, we add instruction that this is a two-tailed test. If our alternative hypothesis was mu is greater than 0, then this would be a one-tailed test and we'll add larger instead of two-sided. Similarly, we add smaller if our alternative hypothesis was mu is less than 0. But in this case, this is a two-tailed test and hence we use two-sided as our option. Then we can just use a series of print commands to output the ztest statistic, p-value, and the result of our hypothesis test. So for this hypothesis test, our ztest statistic is negative 0.39 with a p-value of 0.69, which is larger than our selected level of significance of 0.05. Hence, we accept the null hypothesis that the average daily return on S&P 500 index for the first decade of 2000 is equal to 0. Let's see how we can test our hypothesis using a t-test. We can use the ttest_1samp function from the stats library to perform a t-test as follows. We enter the value under the null hypothesis as 0. The default for this t-test is a two-tailed test, and that is what we need for this problem. Executing these lines of code gives us an output similar to the output from the ztest above. Now let's see how we can perform a two-sample z-test. Let's test if the daily return on S&P 500 index was larger during the second decade of 2000 than the daily return on S&P index during the first decade. So our null hypothesis can be written as mu1 minus mu2 equal to 0, where mu1 represents the return on the S&P index during the second decade, while mu2 represents the return on S&P index during the first decade of 2000. Our alternative hypothesis, or the claim we want to test, can be written as mu1, or the return during the second decade, is greater than mu2, or the return during the first decade of 2000. This can be rewritten as mu1 minus mu2 is greater than 0. Let's download the daily S&P index prices from Yahoo Finance for the second decade of 2000. Let's call this new dataset as SPY1. Select the start date as 2009-12-31 and the end date as 2019-12-31. Once we execute this code, Python will pull the S&P index data from Yahoo Finance for the second decade of 2000. Now let's calculate the log return by executing the following line of code. And let's also drop the first row of the dataset with missing value for log returns. The Python code to compute the ztest statistic and the associated p-value for a two-sample test is similar to the one we used above for the one sample. We add the second variable as x2, and since this is a one-tail test where we want to test if the difference in mean is greater than the value of 0, we add larger in the alternative option. We can add several print commands to print the findings which document that the p-value is greater than the selected alpha of 0.05. Hence, we accept the null and conclude that the returns on S&P 500 index for the first decade of 2000 are statistically equal to the returns on S&P 500 index during the second decade. Now let's evaluate the same hypotheses using a t-test. Since the two return series are from different time periods, they can be assumed to be independent, and we can also assume that the two return series would have equal variance. In this case, we can use the ttest_ind function from the stats library. We enter the two return series, followed by the equality of the variance assumption. If the equality of the variance assumption is not met, then we can just enter the option for equal variance as false. The default option for this t-test is a two-tail test. Since we are performing a one-tail test, we need to divide the calculated p-value by 2. The output shows that the results from the t-test are consistent with the ones from the z-test. The process discussed thus far works only if the samples are independent. If the two samples are dependent, then we need to use ttest_rel function from the stats library. For example, if we want to test if the returns for S&P 500 index are different from the returns for Russell 1000 index during the first decade of 2000, the two return series will not be independent. Most of the S&P 500 constituent stocks are also part of the Russell 1000 index. Hence, in this case, we will use a ttest_rel to test our hypotheses. Since this is a two-tailed test, we can write our null hypotheses as return on S&P 500 index or mu1 minus the return on Russell 1000 index or mu2 equal to 0 versus the alternative hypothesis of mu1 minus mu2 is not equal to 0. Let's download the daily Russell 1000 index prices from Yahoo Finance for the first decade of 2000. Let's call the new dataset as RUI. This is the ticker symbol for Russell 1000 index. Select the start date as 1999-12-31 and the end date as 2009-12-31. Once we execute this code, Python will pull the Russell 1000 index data from Yahoo Finance. Now let's calculate the log returns by executing the following line of code. And let's also drop the first row of the dataset with the missing value for log return. Finally, we can use the following code to perform the t-test for evaluating our hypotheses. The output documents that the difference is not statistically significant at 5% level of significance. Hence, we accept the null hypothesis and conclude that the returns on S&P 500 index during the first decade are statistically equal to the returns on the Russell 1000 index during the same time period.